Hello, and welcome back to another VMK in the game development series. In this VMK, I'm going to introduce you to the ability to add different quality in textures that you're loading from a file. Right now, we've hard-coded the filtering that's applied to all the textures that we load in. However, this is one parameter that you would want to give the users that play your game the ability to manipulate. So if they have a fast computer, they can crank up all the settings to give high quality output. However, if their computer is not so great, or their video card isn't all that great, then maybe they want to be able to tune down some of the graphic settings so that it doesn't bog down the system and the game actually runs a little quicker. In this video, I'm going to show you how you can implement this sort of feature. I'm not going to give you the GUI to do this, but I will show you how to programmatically allow you to change the quality of the textures that we'll be rendering on the screen. We start off by going inside of our texture class, since that's where all the filtering will happen. Inside here, we'll open up the .h file as well as the CPP file. And you'll notice here inside Create Texture OpenGL, we currently have the following filters applied. We're using both a minification and a magnification filter. And what this does is, depending on how far your geometry is from the camera, OpenGL decides how to filter the texture images so that when you render them on the screen, they look however you want them to be. Well, right now, we've hard-coded GL nearest here to be the setting for both of these. So that's what we're using right now. However, we want to give the ability to the user to be able to change these parameters to different settings so that you can have different kinds of filters. Now, the textures that we're using have no MIP mapping on them. MIP mapping is the ability to take a texture. For instance, let's say we start off with a texture that's 64 by 64 pixels in size, and then generating automatically textures that are exactly half that size all the way down to 1 by 1 pixel. So if you MIP map something that is of 64 by 64, you're going to get a set of images for 32 by 32, 16 by 16, 8 by 8, 4 by 4, 2 by 2, and then 1 by 1. Now, what OpenGL will do with these textures is, depending on how far you are from the object that has this texture applied, OpenGL then decides which of these following textures it should use. And this is helpful because you can imagine if you're standing very far away from, let's say, a box. Let's imagine in our minds we have a world that has a box in it, just a regular plain old box. And we apply a texture to that box. Well, when we're standing really close to this box in our 3D scene, the box itself could take up maybe 300 by 300 pixels on the screen. So if the texture image, which we use to apply onto this box to render it to be some sort of shape and color, well, it's going to be mapped onto this 300 by 300 pixels. But now imagine as we start walking away from the box, what will happen? Well, the pixels that are associated with the box will start to shrink because the box is getting further and further away. Let's go into Paint Shop Pro, and I'll try to draw this so that you get a better appreciation of what's going on. Okay, let's say here's our screen. And on our screen, we have some sort of box, a three-dimensional box, but I'm just going to draw it as a two-dimensional one, which we see on the screen. And on the screen, for instance, this could be 300 by 300 pixels. And of course, the dimensions of the screen will be something larger, so maybe, I don't know, 480 by 600, or 640 by 480. Okay, let's say we have this situation. Well, if this box has a texture applied to it, all the texture coordinates that are used to map onto this 300 pixels is automatically handled by OpenGL. So it determines which pixels from the image get mapped into these 300 pixels on the screen. Now, what happens when we move away from the box? Let's say we start moving backwards. Well, this box will start appearing smaller and smaller. So if we move very, very far away, maybe this box will look this big on the screen. In this case, this box maybe could be represented by 100 by 100 pixels rather than 300 by 300. But the texture which we use to map onto this box doesn't change. The texture still has exactly the same amount of pixels. So we have to figure out how to map all the pixels from the texture, we have it here, into now this 100 by 100 pixels. And this is where the filtering comes in. So the filter decides, okay, how many pixels do I have in our texture and how many pixels do I have on the screen? And then it figures out which pixels of the texture to use when rendering on the screen. Well, mip mapping is the ability to take a large texture and convert it into a bunch of smaller textures that sequentially get smaller and smaller and smaller. Then, when we use mip mapping technique, as this box gets further and further away from our camera, the mip mapping decides, okay, instead of using this large texture to map onto this object, let's use a smaller one. Because by using a smaller texture of the same item that we have rendered, we can then get a very crisp image on this box. And it actually cuts down processing. Because you can imagine, if our original texture here was 1024 by 1024, and we're standing very far away from a little box, well, it's going to have to go through all 1024 by 1024 pixels and figure out how to map it into this small area. But if we use mip mapping, well, the mip mapping technique could say, okay, this one's too big, and work its way down, and maybe it decides, okay, 128 by 128 is the size of the texture it should be using to map onto this size. And then it's using pretty much all of the pixels from the texture onto the object. So this is why you would want to use mip mapping. It makes your images actually look much, much cleaner. And the filtering technique, you can choose how you wish to filter the images that do get reduced or enlarged to give you a crisper look. So let's go back into our code now and take a look on how we can implement this. Inside here we have hard-coded to use the nearest filter for both the minification and the magnification. Well, we're going to create some variables that will control the quality factor. And then whenever we load in textures, we'll specify what quality do we want to use when creating the texture for OpenGL. And then that's going to be the texture that's going to be used from then on. So back inside texture.h here, under the private members, we're going to add the following. We add a Boolean value, which is going to say yes or no in terms of whether we want to use mip mapping or not. And then we have this structure, which I'm going to show you how to create in a second, which is going to be the filter quality. And the member variable is just called mFilterQuality. For the filter quality structure, I'm going to put it right here underneath TGA header. And we have 4 settings. We have quality 1, quality 2, 3, and 4. Quality 1 is going to be the worst quality. In other words, it's going to give you the fastest response, but it's not going to look as good as the other ones. Quality 4 is going to look the fastest, and it's also going to be the computationally most expensive out of all of these filtering techniques. So just set this up, and then what we need to do is modify our constructor. Because whenever we create a new texture, we're first going to call the texture constructor, and then after that we'll call create texture OpenGL. So whenever we first use the constructor for texture, we're going to have to pass in a couple parameters. We're going to pass in whether we want to use mip mapping with this specific texture, as well as what is the texture quality we want to use with this specific texture. Let's save that and go back into the CPP file. Back to the constructor. Okay, so we have to add in our 2 new parameters, and then at the bottom here we need to initialize them. So we'll just set mb mipmap equal to bmipmap and m_filter quality equal to quality. Okay. Now we need to make some decisions on what to do whenever we go and call create OpenGL or create texture OpenGL. Down here, after we bind, actually, you know what? I'm going to delete these two lines, move the wrap texture to the top here, and right underneath wrap, I'm going to put the new code. So, if we're using mip mapping, then we have 4 different texture qualities we can apply. Quality 1, 2, 3, or 4. And again, quality 1 is okay, quality 2 is better than quality 1, quality 3 is better than quality 2, and quality 4 is the best one we can do, and it's also better than quality 3, 2, and 1. So if we use quality 1, we're going to set the magnification filter to GL nearest, and the minification filter to GL nearest mitmap underscore nearest. This is the settings that give you quality 1. Quality 2 we have here. Again, we use nearest for the magnification, and for the minification we use nearest mitmap linear. Here we use nearest mitmap nearest. Quality 3 we use magnification filter of linear. Same thing for quality 4, we use magnification filter linear. And then the minification filter, we have linear mitmap nearest, and then linear mitmap linear. So there you go. That's the 4 different quality settings we can set up to use whenever we're using mitmaps. If we're not using mitmaps, we only have really 2 different quality settings. So to handle this, what I've done is I've said if you specify quality 1 or quality 2, then you're going to have these settings. If you use 3 or 4, then you're going to use these settings. So in other words, there's no difference between quality 1 and quality 2 when using no mitmaps. There's only the difference between quality 2 and quality 4. But you can still specify to use quality 1, in which case it's just going to default to use quality 2. For minification and magnification, we use nearest for quality 1 or 2, and we use linear for quality 3 or 4. Now the other thing we need to do here is we are currently loading the texture into video memory using this technique. Well, this only works if we don't use mitmaps. If we do want to use mitmaps, we have to do a different technique. So what I'm going to do is I'm going to go and put this into an if statement. So if we're using mitmaps, we then need to call GLU build2d mitmaps. This is the function call that's going to create all those successively smaller images for us and store them in OpenGL and handle them all automatically for us. So we basically pass in pretty much the same parameters we did here for GL texture image 2D. However, you'll notice there's some parameters that are missing. That's okay because they're not required by this function call. So there you go. And again, we still use the exact same image data that we did down here as we did before. And underneath that, we have the same stuff that we did before. We just released the image data since OpenGL will now be handling everything for us, and we go and call disable textures since we don't want to use this specific texture until we actually attach it to a specific object. Okay, let's go and try to compile this, make sure that I didn't make any errors. Okay, that looks fine. Now we need to go back into our scene, and inside our scene initialize, anytime we load textures, we now need to load them using the new constructor. So what I've done is I've actually created a scene here with 6 boxes on the screen. And to show you this, what I'm going to do is I'm going to go in everything underneath create a scene graph. I'm just going to delete this. I'm going to delete all of this, and I'm just going to paste in the code and then step you through everything that I've written. Okay, actually before I show you here the code that I've written, let me describe to you what I'm going to be rendering on the screen. I'm going to create a very simple scene that has 6 boxes on the screen. So we're going to have 6 boxes, 3 to the left of me and 3 to the right of me. All the boxes are going to be the same shape and size, unlike my drawing here. And I'm going to set them up as following. The first two boxes, so these two here, are going to contain no mip mapping. And these four here will use mip mapping. Okay? Now, as I said before, when you have no mip mapping, you only have two different texture qualities. I'm going to set up the boxes on the left so that this first box will have quality 1 and this last box will have quality 4. Then the ones that are using mip mapping, I'm going to set them up so that this is quality 1, this is quality 2, this is quality 3, and this is quality 4. So when we're looking at the boxes on the screen, this box on the far right should have sort of the highest, crispest quality. This one on the left should be the worst out of all of them. Okay? So now let's go take a look at the code. So at the top here, I define 6 unsigned integers, and these are going to contain the ID numbers for each of the 6 textures which we're going to be using. And you're going to be tempted to say, okay, I have one texture that I'm going to be applying to all 6 boxes. Let's just use the same texture for all the boxes. Well, you can't do that with the framework that I've set up, because the texture manager is going to keep track of all the textures that you try to load in. And if you try to reload the same texture multiple times, it's not going to let you do that. It's only going to use the very first instance of the texture. So to avoid all that problem, what you're going to have to do is create 6 identical textures for this demonstration to work. Each texture is going to be loaded using the following technique. We use pTexture here, which is a pointer to a texture. We pass in our regular values, and you'll notice here with the first one, I'm setting false for the parameter that says whether we're using mip mapping or not. And then here I'm specifying the quality factor to be quality 1. If this succeeds correctly, then we load the texture into this pTexture variable, and the texture we're loading is going to be called crate_1.tga. So to get this texture, what you can do is go inside your resources folder, and you should currently have the following files. From the previous VMK, you should have crate2x2.tga. Well, what I want you to do is copy this texture and paste it 6 times inside this window. And then go inside here and just rename these crate_1, crate_2, and so on. So we're going to be using the exact same texture, but once we load it into OpenGL, we're going to filter it so that it's actually containing different kinds of data inside the video memory that OpenGL will be using when we render things to the screen. Okay, we've defined our textures, so we can go back now and take a look at what else I've done. So this is the first one. The second one, we just set the quality to 4, with remaining here false for no mip mapping. The next guy, we're going to use mip mapping, so we have true, and then we set it to quality 1, quality 2, quality 3, and then quality 4. Then I've defined a material here. It's kind of greenish in color, and this is just the material that is going to be overlaid on the ground that we're walking on. So I just set up the standard parameters here. And then I create my geometry, which is the box that we're going to be rendering to the screen. So the box is 0.36 by 0.36 in size with 0.36 in height. And then I go and create all the nodes that define where all the geometries are in the scene. So I create one root node here that just moves back 2 units in the scene. And then I apply the flat grid geometry nested underneath this root node here. So I saved the geometry, and then I nested underneath that root node. And I also assigned the material. You've seen all this before. I'm just going to step through it really quickly. Okay, here's our first box. I move it 0.95 units to the left, and I take the shape node and assign it to that transformation, and I'm assigning the first texture to this shape node. I then have the second transformation for the second box, which is 0.57 units to the left, and again here I'm assigning the second texture. Then I have box 3 with 0.19 in the negative direction using texture 3. Then box number 4 is 0.19 to the right of the x-axis and using texture 4. Box number 5 is 0.57, and the last one is box number 6 is 0.95, and that's it. Okay, so let's go and save this and build it and take a look. Now, I'm not sure whether you're going to be able to see everything correctly in the video once it's compressed and submitted onto my website. So you may have to do this yourself and run it on your computer to see the differences. Some of the differences are subtle, but they are there. Okay, so there's the 6 boxes on the screen, and the best way to take a look to see how this is working is to step a fair bit away from the box. Now notice that the boxes on the left side look very sharp and jaggedy, whereas the boxes on the right hand side are actually you can almost imagine them as being a little bit blurry, but they're actually very nice, like they're crisp. If we go close to them, you can see a little bit closer to how the filtering technique is being applied. So go ahead and play around in here and take a look to see which filtering technique do you like. Maybe you don't like the way that the filtering on the right hand side is being applied to give the results to the texture. Another thing you can do is maybe this texture that I'm using to demonstrate this technique is not really representative of how it should be working. What you could do is apply a different texture to your boxes and see a more definite change between the boxes on the left and the boxes on the right. So anyway, going through here, you can get an appreciation for how mip mapping as well as the filtering works. You'll notice that with the boxes on the right, as I move closer, the images get crisper. As I move further away, they sort of get filtered and they look slightly different. And that's because the mip mapping technique is actually applying a different texture to the boxes depending on how far we are away. Whereas the boxes on the left-hand side, which are not using mip mapping, well, they're completely just dumping all the texture data onto the geometry, and there is no sort of swapping happening in between. So the objects themselves don't look nearly as good with no mip mapping as with mip mapping. Now, one thing I don't think I've mentioned yet is when you use mip mapping, you're going to be using more video card memory, because you need to store all these extra different textures for the different sizes in between. So just something to be aware of. If you use mip mapping, you're going to be using more video memory, but your images are going to look clear. Okay, so that's it for this video. In the next video, I'm going to show you how to implement the transparency parts into the textures, because right now you can't make your textures transparent, or at least it's not going to work properly. So I'm going to go show you how to do that in the next video.